Assalamualaikum and hi everyone. Today our group will present our project instrument for this SEP and our title, which is monitoring temperature using thermocouple. I will talking about table of content for our slide. First, introduction, system overview, signal characteristic, signal conditioning circuit, implementation result, application irrelevant, then conclusion. Our group mates, which is for I am 2220111 Warren Anis Amalin binti Wan Yusof and 2220104 Nur Syakiri Adani binti Mas Zahar and 2220870 Nur Amirah binti Abdul Wahab and 2222014 Munirah binti Rojihan. Introduction. This project monitor temperature using NTMP36 intercircuit. Otherwise, we use thermocouple MAX6675 for Arduino Uno. The system uses 3 LED to indicate temperature level, which is red, green, and yellow. For red, for hot temperature, green, warm temperature, and yellow for cold temperature. Which is for hot we set for higher than 60 degree, and for warm between 30 to 60 degree, and cold for below 30 degree. It is simple and effective way to visualize temperature condition. Next, we go for system overview. What our objective for our project? To monitor temperature using a TMP36 or thermocouple 6675 and display status via LEDs, which is red, green, or yellow. What component we use to our project, which is thermocouple MA6675 or TMP36 for temperature sensor, or Arduino Uno for microcontroller and 3 LED and resistor, breadboard, and jumper wire. Okay, next I will talking about working principle. TMP36 or thermocouple C675 will detect temperature and set analog voltage to Arduino, and Arduino convert voltage to temperature value. Based on temperature, if below than 30 degree, yellow LED, which is cold temperature, and if between 30 and 60 degree, green LED, which is warm temperature, and if 16 above 16 degrees, which is red LED, which is hot temperature. How system flow for our project, which is TMP36 or thermocouple 6675, go to Arduino Uno and temperature check, and next for LED indicator. And for lastly is our tools we use with Arduino IDE and Tinkercad for simulation. That's all.
In our real project, we use a thermocouple with the MAX6675 module to measure high temperatures. It changes a small voltage into digital data, which is more stable and less noisy. But in Tinkercad, we use a TMP sensor instead. It gives an analog voltage based on temperature, like 750 millivolts at 25 degrees Celsius. This voltage is small and can get noisy, so we need signal conditioning to make the signal stronger and more stable in both setups.
Problem in the system is a key-type thermocouple generate a small voltage varying in the range of microvolt to microvolt proportional to the temperature difference between the hot junction and the cold junction. And the output is around 41 millivolts per degree Celsius. The polarity is positive to chromium, negative is aluminum, and which is around 3200 until 100 and 1350 is a non-linear response. It's identify issue, so it have a low voltage, output is microvolts, requiring applications, noise, susceptible to EMI and power line interference, and its linearity requires compensation for accurate readings. So Choosing signal conditioning method, selection of MAX6675 as a signal conditioning module. So the MAX6675 is a digital thermocouple interface that simplifies signal conditioning by amplifying the thermocouple signal, performing co-junction compensation and converting the analog signal to digital. So Next, next, I am Mira and I will explain about signal conditioning circuit. So in this project, we developed a temperature monitoring system using two different setup. Which for hardware implementation, we use a Type K thermocouple connected to the MAX6675 module to sense and condition the temperature signal. For simulation in Tinkercad, since MAX6675 is not available in Tinkercad, we simulated the system using a TMP36 analog temperature sensor, which directly output voltage proportional to the temperature. However, both setup follow the same concept of signal conditioning output control using Arduino Uno. Temperature sensing Type K thermocouple. The Type K thermocouple detects temperature and produces a very small voltage, which is approximately 41 microvoltage over Celsius. This voltage is too small and unstable to read directly by Arduino. Therefore, we use a signal conditioning module, the MAX6675. Then the signal conditioning, which is MAX6675 module, the MAX6675 performs several important tasks, which is amplification. It will boost the small temperature thermocouple signal. Then cool junction compensation with correct measurement based on room temperature, and it also do the filtering, reduce electrical noises, and analog to digital conversion ADC, convert the analog signal to digital format. The process digital temperature data is then transmitted to Arduino via SPI communication. So here the simulation, which by TMP36 in Tinkercad. In the simulation, we use the TMP36 sensor, which directly output a voltage proportional to the temperature. So Arduino reads this analog voltage through its AO pin and convert it to temperature using simple formulas. And processing and output by Arduino Uno. So Arduino receive the temperature data either from MAX6675 in hardware or TMP in simulation, and Arduino then compares the temperature and control the three LEDs accordingly, which is the yellow LED color is for lower temperature range, which lower than 30 degrees. Green is for normal, which range 30 degree until 60 degree. Then the red is for high temperature range, which above 60 degree Celsius.
Now, let's take a look at the results from our real circuit and simulation using LED indicators to show temperature levels. In the real circuit, we use a thermocouple with the MAX6675 module. It sends digital temperature data to the Arduino through SPI. Based on the temperature, three LEDs show the current range. The first one is yellow LED, which represents temperature below 30 degrees Celsius. The second one is green LED, which represents the normal range, temperature between 30 degrees Celsius to 60 degrees Celsius. And the last one is red LED, which is above 60 degrees Celsius. These LEDs give a quick and easy way to understand the temperature without looking at the screen. In the simulation, we use a TMP sensor instead. It gives analog voltage based on temperature, which the Arduino reads using its ADC. We use the same LED logic in our code. As we change the simulated temperature, the correct LED turn on. Both setups work well. The LEDs reacted instantly as the temperature changed. This shows that our signal conditioning and control system works in both real and simulated environment and is useful for simple temperature monitoring application.
Now let's move on the relevance and real-world application of signal conditioning in instrumentation like our project. Although our project focus on monitoring room temperature using K-type thermocouple and the MAX6675 module, the concept of signal conditioning is actually used in many important industries. So, I would like to explain the real-world application of signal conditioning and how it's applied specifically to our project involving a thermocouple sensor. This process is widely applied in many industries, such as in the medical field. Signal conditioning is used in ECG, electrocardiogram, and EEG, electroencephalogram. They are medical tests that measure electrical activity in the body, where ECG focus on our heart and EEG focus on our brain. In industrial environment, it used with sensor that monitor parameter like temperature, pressure, vibration in control system, such as thermocouple, anemometer. Next, in industrial settings, the thermocouples are widely used to monitor furnace and chemical process temperature. This environment often have a lot of electrical interference. Signal conditioning like cold junction composition and noise filtering is critical to get clean data for control system like PLCs. In the automotive sector, signal conditioning play a vital role in systems such as engine, control unit, and anti-lock braking system (ABS). It ensures the quiet and precise response. So why it valuable? So, raw sensor signal often tweaks, noisy and inconsistent. Without proper conditioning, it can lead to inaccurate reading or system failure. So, by applying, filtering, sometimes converting these signals, we can ensure that the signals are stable and reliable, which is critical in systems where safety, performance and accuracy are met. Lastly, in aerospace and defense, sensors used in aircraft engines must work under high heat pressure and vibration. Signal conditioning helps to amplify, stabilize and digitize these signals so they can be safely used by aircraft monitoring systems. So what about our project? Our room monitoring temperature system also needs proper signal conditioning. The K-type thermocouple we use only produce around 41 microvolt per degree Celsius, which is extremely small and very sensitive to noise. To solve this, we use the MAX6675 module, which amplifies the signal, filters out unwanted noise, and applies cold junction composition. It also converts the analog signal to a digital one that our microcontroller can read easily. This gives us accurate and stable temperature readings even in a simple room monitoring system like us. To conclude, our project is signal conditioning is a key part of modern instrumentation, whether in the car, hospitals, factories, or airplane. It allows us to turn weak, noisy sensor signal into accurate digital data. In our project, we solve the issue of inaccurate thermocouple readings by designing a proper signal conditioning setup, and as we shown today, this principle is just important across all industry that rely on precise sensor data.